This topic is all about problem solving with radians using the key formulae for arc length and sector area to find area and perimeter of complex regions. Okay, so reminder obviously about the formulae that you need to know. So you must know that 2 pi radians is equal to 360 degrees, which is the same thing as saying pi radians is equal to 180 degrees. And the formula that you need to know is L is equal to R theta and A is equal to half R squared theta. Theta is equal to angle in radians. So you must have it in radians or else these formulas would fall apart. Okay, so let's go through a few examples. Okay, so it says given that AC is equal to 8 centimeters, so the whole thing is equal to 8 centimeters. And M is the midpoint of AC. So if it's the midpoint, half of 8 is 4 centimeters. So M to C will also be 4 centimeters. NM and OM are arcs of the circle. So that means this is the center, A and C. 30 degrees, because we're in radian measure, I'm assuming I need to convert that. 30 degrees over 180 degrees times by pi gives you 30 over 180 pi, which is equal to pi over 6. Okay. Show that the shaded region is given by this. Okay, so first thing I would do is I would split up this. Okay, so if I split this up, I've got a right angle triangle with an angle of pi over 6. Okay, somewhere here I've got this arc length. I'm trying to find this shaded region. This is N. Let me label the points. This is M, this is A, and I know this is 4 centimeters. Okay, so first thing I'd work out is the area of sector ANN. So area of sector, so let's just draw it out so you can see it's ANM is equal to half R squared theta, which is half 4 squared times pi over 6, which gives me 8 pi over 6, which is 4 over 3 pi. So that would be the area of the sector. Okay, sector. So I should have done a bit curly here. Okay, next thing is I want to work out the area of the triangle. So if I have the triangle, so if I have, using obviously SOHCAHTOA, I've got adjacent, and I'm trying to work out this. So if I want to work out the area of the triangle, I need the base and the height. Yes, I'm trying to work out this question mark. So using tan theta is equal to opposite over adjacent, I have tan of pi over 6 is equal to question mark opposite over 4. So that means question mark is equal to 4 times tan pi over 6. So this question mark is equal to 4 root 3 over 3. So that is 4 root 3 over 3. So if I want to work out the area of the triangle, now this triangle is AMN, then it's half times base times height, which is half times 4 root 3 over 3. Okay, I end up getting 4 times 4 root 3 at the top, which is 16 root 3 over 2 times 3 at the bottom, which is 6. If I simplify that, I get 8 root 3 over 3. Okay, so if I want to work out the shaded area of shaded part, so this shaded part here, area of shaded part, it must be area of triangle. So area of triangle, take away area of sector, which is equal to 8 root 3 over 3 take away 4 over 3 pi. Okay, now remember the original question is this part. Okay, so this part is two lots of those because I just worked out one lot, yeah? So shaded region, the shaded region is equal to two lots of 8 root 3 over 3 minus 4 over 3 pi. Now I need to somehow make it look like what we have obviously as an answer. So let's multiply by 2 everything, expand the bracket, so I get 16 root 3 over 3 minus 8 over 3 pi. Okay, now the common thing here is the over 3, definitely. 16 and 8, so the numerical part has 8 in common, so 8. There's nothing else in common, so inside the bracket, I'm going to get 8 over 3 times what gives me 16 root 3 over 3. I must have 2 root 3. And the only term that's missing in the second term is pi. And that is what I wanted. Because the units for length were centimeters, the area must be centimeters squared. And that is it. So I've shown that is equal to this. Okay, next question. The diagram shows the sector OAB of a circle of radius r. The area of the sector is 15 centimeters squared and AOB is 1.5. So this is 1.5 radians. Prove that r is equal to 2 root 5. So A. So using A is equal to half r squared theta. The area they've told us is 15. So 15 must be equal to half times radius, which we don't know, times by theta, which is 1.5. Okay, which means 15 must be equal to r squared times 0.75. If I do 15 divided by 0.75, I get r squared, which means r squared must be equal to 20. R must be equal to root of 20, which is root of 4 times root of 5, which is 2 root 5. The question was in centimeters squared, so radius must be 2 root 5 centimeters. So r is 2 root 5, r is 2 root 5. Okay, B. Find in centimeters the perimeter of the sector OAB. So perimeter of the sector is r. So it's going to be r plus this part, which is the arc length, which is equal to r theta. So perimeter is equal to r plus r theta, which is equal to 2 root 5 plus 2 root 5 plus 2 root 5 times 1.5, which gives us 3 root 5 plus 2 root 5 plus 2 root 5, which gives us 7 root 5. Again, the units are centimeters. The segment R shaded in the diagram is enclosed by the arc AB and the straight line AB. Calculate to 3 decimal places the area of R. So the area of R, again, is area of sector take away area of triangle. Okay, area of sector is equal to half r squared theta, which is half 2 root 5 squared times 1.5, which gives me 15. Area of triangle is equal to half r squared sine theta, which is half times 2 root 5 squared times sine 1.5, which is equal to 9.97494, blah, blah, blah. So area, area of R is equal to area of sector, which is 15, take away area, so area of sector, take away area of triangle, which is 9.97494, which is equal to 5.025050, which is equal to 3 decimal places, 5.025, and because the units are centimeters, so its area of R will be centimeters squared. Okay, next question. The diagram shows triangle ABC in which AC is equal to 14 centimeters, BC is equal to 8, and angle ABC is equal to 1.7. Find the size of angle ACB in radians. Okay, ACB is this, so this is what we're trying to find out. Now, because we don't have the opposite length here, let's find out y first, and then we can work out x. Okay, so because we have an opposite length and angle, we can use sine rule. So using, again, we're trying to find an angle, so make sure you have the angle on top. So using sine A over A is equal to sine B over B. We get sine of 1.7 over 14 must be equal to sine of y over 8. Which means sine of y is equal to sine 1.7 over 14 times 8, which means sine of y is equal to 0.56666. Y is equal to inverse sine of that, so inverse sine of 0.56666, which gives me a value of 0.6024, which means if I want to find out x, so that means angle ACB is equal to x. Because angles in a triangle add up to 180, which is pi, it must be pi, take away 1.7, take away 0.6024, blah, 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 which gives me a value of 0.83913, which is 0.84 radians. Okay, the point D lies on AC, such that BD is an arc of a circle center C. Okay, which means C to D, because it's arc, that must be 8. Okay. Find the perimeter of the shaded region bounded by the arc BD and the straight lines AB and AD. So we're trying to find that shaded. So perimeter, which means I need to find this, I need to find this, and I need to find that. Now, because the whole thing A to C is 14 and D to C is 8, A to D must be equal to 14 take away 8, which is C. So length of A to D is equal to 14 take away 8, which is equal to 6. Okay, next, let's work out this. Let's call this L. So arc length BD, which is equal to L, is equal to R times theta, which is equal to 8 times theta is what we just worked out, x, which is equal to 8 times 0. 8 times 0.83913, blah, 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 which gives me a value of 6.71311, going on forever. The next thing I need to work out is this. Let's call this, I don't know, M. So if I redraw my triangle, so this is B, this is A, this is C. I know this is 1.7. I know this is 14. I'm trying to work out this, which is M. and I know this is 0.84. So because I'm finding a missing length, using A over sine A is equal to B over sine B, I get M over sine 0.83913, blah, blah, blah. So the non-rounded version is equal to B, which is 14 over sine 1.7. Which means M is equal to 14 over sine 1.7 times sine 0.83913, blah, blah, blah. Which gives me M is equal to 10.5044. So the perimeter of the shaded area will be equal to 6 plus M plus L, as I said before, which is equal to 6 plus 10.5044 dot 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 plus 6.71311 dot dot dot, which gives me a value of 23.2175 dot dot dot, which to two decimal places will be 23.22. Now the units were in centimeters, so my units for the perimeter will also be in centimeters. The diagram shows a cross-section ABCD of a glass prism. AD is equal to BC, which is equal to 4 centimeters, and both are right angles to DC. AB is the arc of a circle, center O and radius 6. Given that angle AOB is equal to 2 theta radians and the perimeter of the cross-section is equal to 2 times 7 plus pi, show that this is true. Okay, so if I want to work at the perimeter of the cross-section, so perimeter of cross-section is equal to 4 plus 4 plus 4 plus arc length AB plus DC. Arc length AB plus length DC. Okay, so first let's work out the arc length of AB. So arc length AB is equal to R times theta, which is 6 times 2 theta in this case, the angle is, which is equal to 12 theta. Now if I want to work out length of DC, okay, so length of DC is the same thing as length of AB. So if I split this up and work out this M, then I have this triangle, which is theta. I have this is 6 and this is M. Okay, then using, because I have opposite and hypotenuse, sine theta, oh, this was 2 theta, sorry. No, this is theta, because it's half of 2 theta. So using sine theta is equal to opposite over hypotenuse. I'm getting sine theta is equal to opposite, which is M over 6. So M is equal to 6 sine theta. So if this is 6 sine theta, then this is also 6 sine theta, which means length of DC is equal to length of AB, which is equal to 6 sine theta plus 6 sine theta, which is equal to 12 sine theta. So the perimeter of cross section is equal to 4 plus 4 plus 12 theta plus 12 sine theta must be equal to what they've given us, which is 2 times 7 plus pi. Okay, which means 8 plus 12 theta plus 12 sine theta must be equal to 2 lots of 7 plus pi. Let's divide through by 2, so I end up getting 4 plus 6 theta plus 6 sine theta is equal to 7 plus pi. If I take the 7 over to the left hand side, I get 6 theta plus 6 sine theta. Take away 3 is equal to pi. If I divide through by 3, I get 2 theta plus 2 sine 3 theta minus 1 is equal to pi over 3, which is what I wanted. Okay. It says verify that theta is equal to pi over 6. So all I need to do is substitute theta is equal to pi over 6 into 2 theta plus 2 sine theta minus 1 is equal to pi over 3. So I get 2 times pi over 6 plus 2 times 2 sine pi over 6, take away 1. If I put the left hand side into the calculator, I get pi over 3, which is equal to pi over 3. So that does work out. So it is true. It says find the area of the cross section. Next. Okay, now that we know what theta is, so see, if I want to work out the length of DC, remember it was 12 sine theta, which is 12 sine pi over 6, which is equal to 6 centimeters. Means if I work out the area of the triangle, so I've got a triangle in front of me, which is A, D, B, C. This is 4 and this is 6. Then area of triangle is equal to, rectangle. I have a rectangle in front of me. Area of rectangle is equal to 4 times 6, which is equal to 24. Okay, so the next thing I need to work out is this shaded area, because if I work out that shaded area and I take it from the rectangle, then I'll get what I want. Okay, so this shaded area, so let's call this R. So area of R is equal to area of cross section, area of sector, take away area of triangle. Okay, so I need to work out the sector first, take away the triangle, and then I get the region that I want, which is R. So area of sector is equal to half times 6 times 6 times pi, 2 times theta, which is 2 times pi over 6, which means I end up with 6 pi. Okay, in a similar way, if I do area of triangle using the area of triangle formula, it's half times 6 times 6 times sine of 2 theta, which is sine of 2 pi over 6. Okay, if I put that into my calculator, I get 9 root 3. So area of R is equal to 6 pi, take away this area of a triangle, which is 9 root 3. So now, remember, I've got this part, I want to take this part off, which is R, this is R. So area of cross section is equal to 24 take away 6 pi take away 9 root 3. So I have to take away this region R. And if I do that in my calculator, I get 20.7389 blah blah blah, which is equal to 20.74. Units are in centimeter, so areas is in centimeters squared. And that would be the answer for that question. Okay, next question. The diagram shows a circle of radius r and center O, in which AD is the diameter. So what I do know is, if we have this here, this is the radius. This is also the radius. This is also the radius. And we know, because the arcs have been drawn, this is also the radius, which means this is an equilateral triangle. Now, if this is an equilateral triangle, because this is also radius, so all these are radius. It's an equilateral triangle. This is 60 degrees, and 60 degrees is the same thing as pi over 3. So all these angles are pi over 3. What I need to first work out is the area, one of these little sections. Because if I work out one of those sections, then I can take away 2 lots of those. So let's rewrite it again. So the first thing I need to do is, because I know these are all R, and this is R, this is pi over 3, then I need to work out one of these sections. One of these sections is the same thing as working out this one. So area of, let's call these red parts R. Area of R is equal to area of sector take away area of triangle. Now, area of sector is half r squared theta. Half r squared theta take away half r squared sine theta. Now, theta in this case is pi over 3, because remember we said they're equilateral triangle, so it's 60 degrees. So that must mean it's pi over 3 in radians. Minus half r squared sine of pi over 3. Now, if you put sine of pi over 3 into your calculators, you realize you get, sorry, let me just copy up, root 3 over 2. And then if you simplify this, you end up getting pi r squared over 6 take away r squared root 3 over 4. So that is one part. So that part, little part there. But those little parts are the same thing as this one and that one. So in order to work out what this is, I need to work out the area of the sector. So area of sector, take away 2 lots of R, because these are R, so 2 lots of R. So area of sector, take away 2 lots of area R. Now, area of sector is just pi r squared over 6. Squared over 6, because I've just worked it out here. But then I need to take off 2 lots of what I've just worked out. which is 2 lots of pi r squared over 6, take away r squared root 3 over 4. Okay, so if I expand it out, I get pi r squared over 6 minus 2 pi r squared over 6 minus 2 r squared root 3 over 4. Okay, if I simplify the first two terms, I end up getting, that should be a plus, because minus 2 times minus r squared gives you positive. Gives you 2 r squared root 3 over 4, take away pi r squared over 6. Okay, you can simplify the first term, so I end up getting r squared root 3 over 2, take away pi r squared over 6. Okay, if I times top and bottom by 3, I get 3r squared root 3 over 6 minus pi r squared over 6. Okay, the common factor here is the over 6 and the r squared. So if I take that out, I get r squared over 6. Inside the bracket, I get 3 root 3 minus pi, which can be written as a 6r squared 3 root 3 minus pi, which is what we wanted. Okay, so it comes from the fact that the solution comes from the fact that obviously theta, realizing theta is equal to pi over 3. And knowing that you have to work out those little bits and take off 2 lots of those little bits from the sector area. Okay, next question. The diagram shows a circle of radius 12. So radius 12 centimeters, which passes through the point PQ. The chord PQ subtends an angle of 120 degrees. So 120 degrees is equal to 120 over 180 pi, which is the same thing as 2 over 3 pi. Okay, find the exact length of the major arc PQ. Major arc PQ is this one, the bigger one. So this is what we're trying to find out. We're trying to find the exact length of that. Okay, so part 1. So if that is 2 over 3, so 2 pi first, because angles in a circle add up to 2 pi. 2 pi take away 2 over 3 pi, which is equal to 4 over 3 pi. So that means this is equal to 4 over 3 pi. So using L is equal to R times theta, L is equal to 4 over 3 pi times 12, which gives you a value of 16 pi. And because it was in centimeters, this must be in centimeters. Part 2 showed that the perimeter of the shaded minus segment is given by k times 2 pi plus 3 root 3 centimeters, where k is an integer to be found. So again, the minor arc. So now I'm looking at the minor arc. So using L is equal to R times theta, L must be equal to 2 over 3 pi times 12, which gives me a value of 8 pi. So I know from there to there is 8 pi. Now if I split up this triangle into 2 and work out this part, which is, or this part, which is M. So if I draw this out roughly, and I've got a right angle triangle. The angle is 2 over 3 pi, so that must be just pi over 3. I know the radius is 12, so this is 12, and let's call this M. So using sine, opposite and hypotenuse, opposite sine theta is equal to opposite over hypotenuse. I get sine of pi over 3 is equal to opposite, which is M. M over hypotenuse, which is 12. So M is equal to 12 sine pi over 3. Which if you put into your calculator, you get 6 root 3. So if I want to, so m is equal to 6 root 3, but don't forget I got two lots of m here and m there. So the perimeter is equal to 8 pi plus m, which is equal to 8 pi plus 6 root 3 plus 6 root 3, which is equal to 8 pi plus 12 root 3. There's a common factor of 4. So if I take it out, I get 2 pi plus 3 root 3, which implies k must be equal to 4. Okay, part 3. It says, find to one decimal place the area of the shaded minor segment as a percentage of the area of the circle. Okay, so area of shaded part must be equal to area of sector, take away area of circle. Okay, that is, we worked out what the radius is now. Radius is 12, so it's half times 12 squared times 2 over 3 pi. Take away half times 12 squared times sine 2 over 3 pi. Now if you put this into your calculator, you end up getting 88.442. Okay, area of the circle. Next we need to work out the area of the circle, because we need to work out the percentage of the shaded as percentage of the area of the circle. So area of circle is pi r squared, which is equal to pi times 12 squared, which if you put into your calculator, you end up getting 452.389. So if the percentage is equal to area of shaded over area of circle times by 100. Okay, which means 88.442 blah 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 over 452.389 blah 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 times by 100, which you get 19.55011.095 blah blah blah. If I'm doing it to one decimal place, I end up getting 19.6. And because it was a percentage, 19.6%. Okay, and that would be it.